Hello student, welcome back to lecture series on numerical methods for solving the solution of a differential equation. Okay, so I already uploaded plenty of the videos in my channel. Okay, so basically the most important method, which is Euler's method I uploaded in my channel. Okay, with some of the important example. If you are interested to see this video, guys, go and check in my description box here, or you can go here to the I button. Okay, you will get the complete video lecture series. So in my today's video, guys, I'm gonna explain to you all modified Euler's method. Okay, so that method I'm gonna explain here. Okay, and in my tomorrow's or next lecture, I'm gonna explain to you all the example based on the modified Euler's method. Okay, I found mostly example based on the modified Euler's method in your university question paper. Okay, so be careful for these methods. Okay, so it is quite similar like Euler's method. Okay, modified Euler's method is similar like Euler's method, but modified Euler's method gives us the very accurate answer compared than Euler method. Okay, and it gives us a very faster answer. Okay, that means to obtain the solution with a desired accuracy, we have to take smaller value for each we are taking. Okay, so we are taking smaller value of each. So as we are taking smaller value, to obtain the solution, it is very slowly. Okay, this solution obtained very slowly, or might sometimes it takes lot of time. Okay, due to the Euler method, it is rarely used. Okay, due to Euler method, it is rarely used. So to more accurate result or to fast result, we always used modified Euler's method. Okay, so modified Euler's method, it is useful for finding the accurate answer and faster answer. Okay, so it is very much important, guys. Okay, let's start the modified Euler's method. Okay, so we know that Euler's formula at the first Euler formula. Okay, at y of y at x, which is equal to y of x1. Okay, Euler's formula of y at x, which is equal to x1. Let me write this one. Euler's formula. Okay, Euler's formula to find value of y, to find value of y at x, which is equal to x1. Okay, so we are taking Euler's formula to find the value of y. Okay, at x, which is equal to x1. So we know that the first iteration for Euler's formula is y1, which is equal to y naught plus h into f of x naught y naught. But we are going to do some of the changes, guys, here. Okay, so these are the changes. That means we are taking it's the first approximation as a power 0. Okay, so we consider this as the approximation for our iteration. Okay, yes. To find more correct approximation, we take at x is equal to x1, we use Euler's modified iteration formulas. Okay, so the Euler's modified iteration formula for more approximation, okay, for more approximation at x, which is equal to x1. For more approximation at x, which is equal to x1, we use modified Euler's formula, that we write y1. Okay, we write y1 to the power n plus 1. Okay, y1 to the power n plus 1, y naught, and we are taking step h by 2 here. Okay, h by 2 under bracket f of x naught y naught plus f of x1 y1. Okay, f of x1 y1 to the power n over here. Okay, so what is to the power n? I will explain to you all, guys. Okay, just see that what I am writing. So see here, guys, I written here the formula for modified Euler's method, as you are going to replace the value for 0, 1, 2. Now see that, guys, this one is the modified Euler's method for only the first iteration. Okay, this one is for only the first iteration. So if you want the second iteration, you have to take y2 to the power n plus 1, which is equal to y1 plus h by 2 f of x1 y1 plus f of x2 y2 to the power n. Okay, that means you have to replace y naught as 1, x naught y naught as x1 y1, x1 y1 as x2 y2 over here. Okay, this many adjustment you have to do that here. Okay, so for finding the initial approximation. Yes, so see that if you are going to replace 0, 1, 2, so you will get the approximation values for our different iterations. So if you are going to put the 0, see that n is a 0, y to the power 1, y to the power 1, which is equal to y naught plus h by 2, f of x naught, y naught, f of x1, y1 to the power 1. Okay, so this is the way you can write the value. So how can we write? If n which is equal to 0, if n which is equal to 0, we write y1 to the power 1. N is a 0 means y1 to the power 1. Okay, is equal to y naught plus h by 2. Okay, under bracket f of x naught, y naught plus f of x1, y1 to the power n. Okay, bracket complete. Okay, when n is a 0, so if you're going to replace n is a 1, you will get the y to the power 2. Okay, so all the values you're going to change, you're going to get it changed. Okay, okay, so that means if n is 1, then y1 to the power 2 is equal to y naught plus h by 2, f of x naught, y naught plus f of x1, y1 to the power 1. Okay, and bracket complete. Okay, this one is for our first approximation or first iteration. Okay, for the second iteration. Okay, so for the second iteration, okay, now see that you will get y1 to the power 1, y1 to the power 2, y1 to the power 3. Okay, so you have to find n number of powers over here, but make sure that we are going to collect the values those who are approximate or close to each other. Okay, that means we are collecting the value y1 to the power n minus 1, which approximately y1 to the power n. Okay, that means preceding or subsequent iteration, we want the approximate equal or close to each other. Okay, so that one we call it as the required answer. Okay, for our first iteration. So if you want, you have to repeat a second iteration. This one is the first. So if you want to repeat second iteration similar like this, so what you can do, y2 to the power n plus 1, just replace y1 instead of y2. If it is y2, then it goes to y1 plus h by 2. Okay, under bracket f of x naught, y naught, we replace it to the next interval, f of x1, y1. Okay, and plus x1, y1 replace, we take it to the next interval, f of x2 comma y2. Okay, to the power n, bracket complete, and n running from 0, 1, 2 and so on. Okay, this one is for our second iteration. So if you want for third iteration, take it y3 to the power n plus 1. Okay, and run value from 0 to n. Okay, you will get the required Euler's modified formula. Okay, so I hope you all have understood. This one is the required Euler modified formula. I did not take it to the more level. Okay, so it is okay. These are the 3 to 4 values more than sufficient to understand Euler's modified formula. Okay, yes, I hope you all have understood Euler's modified formula. And we are going to continue some of the example based on this. Might be most of you all are feeling that what are these equation and this formula is quite difficult to remember, but for your understanding I given here some tricks, guys. Okay, to remember the formula. How can you remember? Okay, so in our next lecture, guys, I'm gonna explain to you all example based on the Euler modified method. Okay, modified Euler's method. Once you solve some of the example, you will get the concept very much crystal clear. Okay, I feel that you will have understood everything here in my today's lecture. Okay, so if you want, you can note it down, these points. These are important here for our next lecture. Okay, so that's it for our today's lecture, guys. So in my next lecture, I'm gonna explain to you all some of the example based on the modified Euler's method. So if you like this my video, guys, let me know in my comment section. Okay, so thank you everyone. Thank you for my today's lecture.